In level 1 for inverse functions, our goal is going to be to determine if functions are one-to-one. A one-to-one function is a function in which any two different inputs corresponds to two different outputs. Now that means if you have two different x values, they would have to have two different y values. So you can't have two different x values with the same y value. Now, remember we used the vertical line test whenever we were determining if something was a function. Now we're going to use a horizontal line test to determine if a function is one-to-one. So if a function touches a horizontal line more than once, it's not one-to-one. So in this first example, we're going to first determine, are these graphs functions? If they are they one-to-one? Because we don't even talk about one-to-one if they're not functions to begin with. The first graph does pass the vertical line test. No vertical line would touch more than once, so it's a function. Yes, function. So now we test the horizontal line test, and a horizontal line touches twice. So it did not pass the horizontal line test. It's not one-to-one. Okay, moving on to the next one. First, the vertical line test. There's nowhere I can draw a vertical line that will touch more than once. So yes, it's a function. And now we try the horizontal line test, and there's nowhere I can draw a horizontal line that will touch more than once. So it does pass the horizontal line test, and yes, it's one-to-one. And the third example doesn't pass the vertical line test, so it's not a function, and we don't even bother thinking about if it's one-to-one because it's not a function to begin with. When you're given an equation and you want to determine whether a function is one-to-one, the easiest thing to do is to picture the graph and then use the horizontal line test. So if I graph f of x equals negative x plus 4. This is a linear equation. It has a slope of -1 and a y-intercept of 4. So it looks something like that. And that is going to pass the horizontal line test. I would never have a horizontal line touching that more than once. So yes, this is a one-to-one function. Now the next one, a radical, again, I'm going to picture the graph. This is a square root function shifted 1 unit to the left. So it's going to look something like that. And again, a horizontal line is not going to touch that more than once. So yes, it's one-to-one. Now we have an absolute value, and if I were to graph this, the vertex is shifted 1 unit to the right and 3 units up. It has the slope of the lines for the absolute value is 2/3, so it's going to look something like this. We're just sketching it. And that is not going to pass the horizontal line test. A horizontal line does touch it more than once, so it's not one-to-one. Okay, and this final example, x squared plus 4, if x is less than or equal to 0. Now, if we graph x squared plus 4, we're taking our parabola and just shifting it up 4 units, 1, 2, 3, 4. So the vertex is right here, but we're only supposed to graph it when x is less than or equal to 0. So that's on the left side of the y-axis only. So I would plot my points to the left, over 1, up 1, left 2, up 4. It would look something like this. But I'm not graphing the right side of it because we have a domain restriction. They're saying only when x is less than or equal to 0. Now since we only graphed half of the parabola, it does pass the horizontal line test. A horizontal line does not touch it more than once. So yes, it's 1-to-1. Now, if this was the whole parabola, x squared plus 4, it wouldn't have been. But since we only graphed that certain part, it is 1-to-1.